Hi, welcome back. In this video, we will see what is epistemology of engineering. Epistemology of engineering is a branch of philosophy that studies how engineers know what they know and how engineering knowledge is created, justified, tested, and applied. In simple term, we can say how do engineers know what they know, what makes the engineering knowledge is reliable, how the engineering knowledge is different from the scientific knowledge. So it differs from epistemology of science because the engineering is not mainly about discovering the truth about the nature. It's also about the designing a workable solution under a real world constraint. The core idea about the engineering knowledge is practical rather than purely theoretical oriented. It aims to solve problems, which means context dependent, often based on models, approximations, and this is going to be validated by the performance, functionality, not just the truth. So if you look at the science and engineering, the science seeks to explain the natural laws, whereas engineering seeks to apply the laws to create solutions. Science basically focus on truth, but engineering focus on usefulness and functionality. Science shows only the theoretical approach, whereas engineering is a design-oriented approach. The best example for science is Newton's law. It just explains a natural law, whereas the engineering designs a bridge using the Newton's law. If you look at the relationship between science, technology, and engineering, these are all closely connected fields that work together to improve the human life and solve many problems. So they forms a continuous cycle. If you take science, engineering, and technology, so these are new scientific discoveries, right? So the science is a systematic study of nature and universe. So it mainly focuses on discovering the fact, understanding the principle, and explain the natural phenomena. So science answers, what does this happen, or why does this happen? This example includes a law of motion, electromagnetism, and thermodynamics, quantum physics, and many more. So for example, if you take F is equal to mass into acceleration, the scientific law explains force and motion. If you look at this picture, this is a electromagnet. The scientist like Michael Faraday discovered this electromagnetic principle. So this discovery from the scientific foundation for electrical engineering. So here, whenever the electromagnets is placed over here, it has N and S poles. Here we'll be having a coil. So whenever the magnet moves forward and reverse, this coil will be generating some amount of current. So this current will be started flowing through this circuit. So here this magnetic field is converted into a electrical energy. So whenever the magnet is moved forward and reverse, the electricity is produced in this coil that will be circulated through this circuit. The engineering answers how can we use this knowledge to solve the problem. In the previous slide, the science, we have seen the electromagnetic principle. This principle can be applied to solve certain problems. So in this particular engineering perspective, they design, build, optimize, and test and improve the system. So this is one of the example. Using this electromagnetic principle, we can able to design and develop a motor. So engineers uses this electromagnetic theory to design the efficient motor used in industries and appliances. So engineering asks, how can we build something that works? Engineering converts the scientific principle into practical applications. Now coming to the technology, technology is the final product, tool, or a machine or a system that is created using engineering. So the technology includes a lot of examples. You can say smartphone, electric vehicle, medical devices, computer communication, electric fan, washing machine. So all those things consider the technology. So the main goal of this technology is the practical use in society. So technology is what the society uses in everyday life. So if you look at the relationship, the flow, science, engineering, technology, this discovers the principle, applies the principle, and produces the useful product. So under technology, we are going to get the product from the engineering output. So here, this electric vehicle. This electric vehicle uses a motor, batteries, and control system designed by the engineer based on the scientific principle. So the technology basically represents what has been built. So if you take all the three together, generates the knowledge, designing a solution, and delivers the application. It's a theory-oriented problem, a theory-oriented as well as problem-oriented as well as user-oriented approach. Now we can see how these three things have been connected. The science, we are going to have an electromagnetic theory. In engineering, we are going to do a design of electric motors. In technology, we are going to apply this electric motor for designing electric vehicle. So if you look at the how to analyze the nature, content and complexity of knowledge base in engineering, I've taken this EV as an example. In nature of EV, it is completely a design oriented concept. The engineer should know how to design EV, a battery, a motor system. And coming to the context dependent, the EV is mainly depends on the EV performance is mainly depends on the climate or environmental condition. So based on climate, this EV performance can change, and based on road condition also the EV performance can change. So this is a context dependent. The third one is a goal driven approach. The main purpose of moving to EV is to reduce the exhaust emissions. So if you look at the content in EV, the content in EV, we are having the motors, the motor design, which has electromagnetics principle, and also we have battery. The battery is having electrochemistry principle, and also we have some power electronic devices and control system, and also we are going to use a thermal management system, which is required for both motor cooling as well as the battery. So this thermal management system is very much required for electric vehicle, and for getting a better speed and efficiency and performance, we need to integrate some AI related algorithm, that's a software algorithm, and also the engineer should strictly follow the safety standards whenever they are designing the EV. Now if you look at the complexity in designing the EV, it's a battery life versus charging speed that get trade-off, then the cost versus performance balancing. Whenever the battery we are using for 5 years or 10 years, the cost wise it is also getting increases, and thermal runaway is risk management is one of the major issue in electric vehicle, and integration of hardware and software is also a little bit complex. This shows engineering knowledge is layered, integrated and dynamic process. So engineering shapes the modern world from smartphones and satellite to the transportation and renewable energy system. So the engineering influences every aspects of human life. So the engineering is not limited to only making machines and technology alone. It is a combination of scientific understanding, technical creativity and social responsibility, and also ethical decision making. To fully understand the engineering, I can just go through this four important dimensions now. The four important dimensions are scientific dimension, technical dimension, social dimension and ethical dimension. We'll see one by one. First one is a technical dimension. So in the technical dimension, so here we are going to see the application of a scientific or a mathematical knowledge in designing the system. So the technical dimensions, we are going to basically focus on some CAD software, manufacturing, some robotics, coding and circuit boards. So the technical dimension focus on transferring the scientific knowledge into a practical application. So this is where the engineering becomes like a design, innovation and technology. So if you see that the engineer performs many technical activities such as for designing a transportation system or designing a bridge system, so creating a prototype and testing their performance, validating their performance and optimize the efficiency. So if you look at the picture on the right side, a civil engineer is started planning to construct a bridge. Before constructing the bridge, the engineer should calculate the load, stress, material strength and safety factors. So this is all considered the technical dimensions. Now we'll move on to the social dimension. In social dimension, this mainly focus on how engineering impacts the people, communities and the environment. Social responsibilities, the engineer must consider the public safety, sustainability, accessibility, environmental impact and the quality of engineers for society. So if you take an example like a smart agriculture or healthcare devices or a water purification system, so the engineers improves society through various technologies like a medical technology, transportation, communication, network, clean energy. There are a lot of examples are there. So in this case, if you see a social dimension for reducing the pollution, for that many people have started moving to electric vehicle or designing of electric vehicle to reduce the pollution. So the renewable energy, the engineers have a design of solar or wind power system to reduce the pollution and provide the sustainable electricity. So next is the ethical dimension. The ethical dimension ensures that the engineering is practiced responsibly and honestly. So the engineering decision affects the human life. So the ethical responsibility is extremely important in engineering design. So ethical responsibility of the engineers should include the safety standards. They must follow the safety standards, risk management, professional ethics, and accountability. So if the engineer ignores the safety standard to reduce the cost, it may lead to accident and disaster. So therefore, the ethical engineering protects both safety as both society as well as the environment. Now coming to the economic dimension, this economic dimension makes the engineering decision must consider cost and feasibility. So that includes a budget constraint, cost optimization, market demand, and resource efficiency. So the civil engineer planning to construct a bridge, they need to select suitable material that balance both cost and durability. So these are the four dimensions of engineering merging into one integrated engineering system. So these four dimensions of engineering is not a separate, they work together in every engineering project. So as we already discussed, the engineering design transforms ideas into reality. But how do the engineer know what design will work and what kind of knowledge do they use while solving complex problem? So these questions are explored in the epistemology of engineering design. So this epistemology is a study of engineering, how this knowledge is created, justified, and validated. In engineering design, the epistemology explains how this engineer will develop the knowledge while designing a solution to the real world problems. So, and unlike scientists who mainly discover only the knowledge, but the engineers create the solution using the knowledge. So engineering design is a systematic and creative process used to develop the solution for a real world problem. So it involves identifying the needs, generating the ideas, analyzing alternatives, building up prototypes, and testing and improving the design process. So the from scratch, the first we need to understand the problem identification. So understanding the problem and the user requirement. And step two, we need to know creating possible solution and innovative ideas. And step 3, we need to do the analysis and modeling. Step 4, prototyping and testing. And the fifth step would be the optimization. So the engineer should be more responsible of doing this engineering design. The epistemology of engineering design studies shows that how engineers acquire this knowledge and how they justify the design decision and how they know the design will work. So if you look at this example problems, designing a robot, or developing a bridge, or creating a medical devices, and designing an electric vehicle. So the engineering design combines all these four phenomena: the scientific principle, mathematical analysis, practical experience, and creativity and innovation. So if you look at the types of knowledge used in engineering design, you have five different knowledge. One is a scientific knowledge. Scientific knowledge provides the fundamental principle used in engineering design. As I already told you, the force is equal to mass into acceleration. This is a fundamental law. So this equation helps the engineer to analyze the force, motion. Likewise, we can use some equations from electrical circuits for calculating the voltage. So like that, we can use a lot of Ohm's law, Kirchhoff's law, and Newton's law. These are the scientific knowledge based on laws and theories. Coming to the empirical knowledge, the empirical knowledge is a knowledge from various experiment. For example, testing a material strength, stress. So this comes under the empirical knowledge. The third one is a heuristic knowledge. This is experience-based rules. So this mainly taken from the safety factors in structures. Then the procedure knowledge, it's a knowledge of process. Using CAD modeling steps, we can get the knowledge from the process. And the final one is the tactic knowledge. The tactic knowledge is the practical skill from the experience. For example, the precision machining is one of the best example where you'll get the practical skill from the experience. So if you look at the characteristics of engineering design knowledge, the characters are maybe solution oriented or iterative process, context dependent or interdisciplinary. So solution oriented means mainly we are focusing on solutions, focusing on how to solve the problems, how to solve the practical problems using a scientific approach. Coming to iteration process basically applied in various systems to improve the process. So it will design and improve through the repeated testing. The third is a context dependent. The context dependent is mainly focused on design dependent on cost and the material what you are procuring and safety standards and environment. And final one is interdisciplinary. The interdisciplinary combines the knowledge from a multiple field. Like I already discussed, the engineering is not only designing a machine and finding a solution for the practical problems. It is also combining various fields. So this is a sequential flow of engineering design knowledge creation process. So this is a design cycle. We need to start from scratch, from problem definition, identification. After problem is identified, we need to get the information about how we are going to solve the problem. So the information collection is the second step. The third step is a concept generation. Based on this information, we have to generate the concept. Then after getting the concept, we need to move on to design and modeling of the system. After designing and modeling, we need to move on to prototype development. After the prototype is ready, we can go for testing and evaluation. Finally, if the prototype is not up to the limit or the expected one, we need to go for design improvement. So this is a cyclic process. So the design cycle has totally this different flow steps. So these steps we need to follow for engineering design of any system. So this process generates a new engineering knowledge of any domain.